Hello friends, welcome back to Rising Mathematics. In this video, I am going to solve exercise question from book Topics in Algebra from chapter 3 Ring Theory. Question is, if U is an ideal of ring R, let R colon U is set of all those elements say X from ring R such that Rx is an element from ideal U for every element R from ring R. Then we have to prove that this set is an ideal of ring R and it contains the ideal U. So proof, we have given that R is a ring and U is an ideal of ring R, and this set is set of all elements X from ring R such that Rx is an element from U for every element R from ring R. We have to prove that this set is an ideal of ring R. For this, number 1, consider any two elements say x1 and x2 from this set. So we have Rx1 is an element from ideal U and also Rx2 is an element from ideal U for every element R from ring R. Then for x1 minus x2, we have R dot x1 minus x2 is equal to Rx1 minus Rx2. Now since both Rx1 and Rx2 are elements from ideal U, therefore Rx1 minus Rx2 will be again some element from ideal U. That is, R dot x1 minus x2 is an element from ideal U, and therefore we have x1 minus x2 will be an element from this set, and so this set is a subgroup of ring R under addition. Number 2, consider some elements say X from this set. Then it is given that for all elements R from ring R, Rx is an element from ideal U. Then for some element say R1 from ring R, we have R dot xR1 is equal to Rx dot R1, which is equal to U1 R1, where this U1 is Rx, which is some element from ideal U. Now since U1 is an element from ideal U and R1 is some element of ring R, U1 R1 will be an element from ideal U, that is R dot x R1 will be an element from ideal U, and therefore x R1 becomes an element from this set. Also we have R dot R1x is equal to R1x, which is equal to R2x, where R2 is R1 in ring R, which is an element from ring R, and therefore R2x will be an element from ideal U, since this x is element from this set R colon U, and therefore R dot Rx1 is an element from ideal U. We have R1x will be an element from this set, and therefore from 1 and 2 we have the set R colon U is an ideal of ring R. Now next, consider some elements say U from ideal U. Now since U is an ideal of ring R, then for all elements R from ring R, we have Ru will be again some element from ideal U, and so by definition this U will be element from this set. Now since U is some arbitrary element of ideal U, and also we get here that U is element from this set, therefore U is contained in the set R colon U, and this proves our result.